So what is this, case 5? And where's the object going to be located this time? On the focal point. Again, unless you have drawn everything out perfectly, sometimes it's hard to get this one to actually work the way it's supposed to work. So you might want to wait until you see. But at first it seems to be like the same old, same old. You know, you go to draw the first ray, no problem. A light ray going parallel to the principal axis, is going to hit the mirror and reflect and go through the focal point. But there's a little bit of a problem now, because the second light ray has always been leaving the object's head and gone through the focal point to hit the mirror, but we can't go from the head through the focal point and hit the mirror. You know, it's not going to work out. So we can't use our standard second ray. Drats. Okay? So we need like a third important ray. So let's just, write a little side note here. Cannot use standard second ray because object's on F. So you can't leave the head, go through the focal point. So we need a third important ray. So let's take the time out, talk about this third important ray. So just to summarize, the first important ray that we've been using all along is a parallel light ray reflects through the focal point. No need to write that down, already have that. Yes? The second important ray that we know is a light ray through the focal point, bounces back parallel. Well, the third important ray, which we have to use in these last two cases, a light ray coming from the center of curvature it's going to be going like right along the radius of the circle. Remember, because this is like a spherical mirror, yes? And if it's going like right along a radius, the radius is right along the normal line. So if the light ray is right along the radius, which is right on top of the normal line, how's it going to hit the mirror? At an angle or head on? Head on. Zero angle of incidence. Therefore, if it hits the mirror head on, because it's right on the normal line, how's it going to reflect back? What's that? No, it's going to reflect. It's hitting the mirror head on. Like if you throw a tennis ball and the tennis ball hits the surface and it hits it flat, head on, it's going to go right back where it came from. Again, a light ray coming from the center of curvature that hits the concave mirror, it hits the mirror right along the normal line. And since it's hitting it right along the normal line, head on, it bounces straight back. Just like if you had a flat mirror like this, and here's the normal line, and if you threw a light ray and the light ray hit the mirror head on, just like that, how's it going to bounce back? Straight up. Same thing here. A light ray coming from the center of curvature hits head on, goes straight back. Yes, no, with me? I personally sometimes call this the backup ray. You know, this is our backup. Call them the backup because you can't use the first two standards. Ready? So let's go back and use our backup ray now. We have our first standard important ray, light ray going parallel to the principal axis, reflects back through the focal point. We can't use the second standard one because the light ray going from the head through the focal point usually doesn't even hit the mirror. So we use our backup ray. Now you might want to watch me on this backup ray because again, if it's not drawn out perfectly, it doesn't work out perfectly. Again, watch carefully. a light ray leaving the object's head and going towards the mirror as if it came from where? The center of curvature. But it doesn't start from the center of curvature. Where does it start? It starts at the object's head and heads towards the mirror. But in such a direction, it's right along the normal line. So it's as if it came from the center of curvature. And when that light ray goes and hits the mirror, it hits right along the normal line. So how's it going to bounce? Straight back through the center of curvature. I'm going to move my center of curvature over just a smidge there. And if it's drawn perfectly, these two reflected rays are parallel to each other. They're not going to come together and form a real image like all the other cases. So no matter if I held a screen and I put a screen here, or if I put the screen here, or I put the screen back there, no matter where I put that screen, I would just see the same size white blob of light. And you never get an image. So basically, the parallel rays do not form any image. It's not real, it's not virtual. If I put my eye in this light and I look back, no image. Because the parallel light rays would go back this way forever and ever parallel. So there's just no image formed. If you wanted to be like mathematical about it, you could say there's an image formed. Guess where the image would be formed? At infinity. But no one even talks about it like that, you know. So basically, no image formed. Reflected rays are parallel.